Hello and welcome to today's webinar. My name is Adam Golov, Marketing and Communications Manager at Data Conversion Laboratory, and I'll be your moderator today. Before we get started, I wanted to let you know we will allow time at the end of the webinar for questions and answers, so please write your questions in the chat area if they come to mind. If we don't have time to answer them all, we will make them available on our website. For those of you who are not familiar with DCL, we convert and organize content to create electronic documents, populate databases, publish on the web, and basically get it ready for tomorrow's technology. DCL services help you refine your document conversion strategy, identify document redundancy, extract metadata, and transform legacy and future documents for real needs, today and in the future. Today, we are thrilled to introduce Nave Greenberg, Director, U.S. Defense Development here at DCL. Nave is a PMI certified project management professional with expertise in large-scale complex conversions, utilizing numerous DTD standards. He specializes in conversions for DCL's defense and tech doc business units and has been instrumental in developing DCL's DITA 2361 and 451 S1000D and 38784 conversion software suites, as well as working with clients to develop detailed project business rules. Nave is a member of the United States S1000D Management and Implementation Group, Land Working Group, and participates in other discussion subgroups. Nave has been with DCL for over 10 years and holds a BE in Mechanical Engineering from Stony Brook University. Without further ado, welcome Nave.
Thank you, Adam, and thanks everyone for attending today's webinar. So today we are going to discuss automated and manual QA. We will try to see how we can find the right balance between automated and manual QA. So first we will cover the most common misconceptions with conversion and with QA. We will also cover the importance of getting the conversion right on the first time. And to get it right, you will need proper planning, analysis, and some knowledge of your source data structure. And what I mean by knowledge of your source data is really being familiar with both consistencies and inconsistencies. And that would be a good segue to the next topic, which is how to mitigate the risk of finding bad surprises in the middle of the conversion process. And these surprises can be very costly, especially if you deal with them in the middle of the process, or even worse at the end of the conversion process. At the end of the webinar, you'll have time to ask questions, and you can always email or call me, and I'll be happy to answer your question. Like last thing before we move forward is that this is really my take on the subject from years of managing conversion projects, and it's mostly related to QA process when converting legacy data to HTML or XML. So, you know, people use QA and QC all the time, but if you ask them what the difference is, many can't really explain it. Almost everyone, including me in the past, used QC and QA interchangeably. And I'm not sure if it's that crucial to know the difference, but because we are dealing with this subject, this webinar, we might as well talk about it. So when it comes to product development, QA is a set of activities that ensure quality in the process by which products are developed, and QC is the set of activities that ensure quality in products once they're already developed. When it comes to conversion, I see QA as the master plan, which makes sure the process of conversion is developed and run correctly. I see QC as being the actual matrix of the quality, basically checking the converted files and finding real issues and fixing them. But if you, let's say, detect the issues and go back and revise your so-called master plan and improving the conversion process and all the checks throughout the conversion process, that I see as a QA. You already changed the process. So the main goal of QA is to improve the development and the quality checks during the conversion process so that the converted files are in good shape. And the main goal of QC is to check and identify issues after the data is already converted. And again, this is the way I see it. So what are some of the misconceptions that contribute to the difficulties in developing a proper QA plan? So let's start with the first one. My data is all over the place, and there's no way to automate anything. So this is why analysis and planning is so crucial. There are always ways to normalize or standardize the source data, making it a lot easier to convert. At the same time, you may find that some data is in such bad shape that you may need to manually tag it or decide that it's not even worth converting. On the other hand, you have people saying my data is very consistent and clean. So this is also not always the case. There are a lot of examples where data may appear to be consistent, but after a good analysis, you find many inconsistencies or variation of the structure, and it's really how you handle these inconsistencies that makes or break a conversion project. And some people say that they will manually tag the data, and that way they can save all the analysis and planning time. So this is not a good approach. I mean, it's one thing if you only have few pages to convert, but when you deal with a larger conversion, this mindset will only cause extra headaches later on in the conversion process. And in addition to taking a very long time to manually tag the data, you also have all the inconsistencies that will be introduced to your data. And if anybody ever had to manually tag data, knows that after a few hours of tagging, your decision making will change, and there is a high probability that you will tag data inconsistently. Next, it validates, therefore it's good. So this is, again, not always a true statement. XML files that validate against a DTD or a schema only guarantee that no tagging rule defined by the schema will not violate it. So it will not tell you if you tag data properly. And when you deal with more complex standards like DITA, ATA, 40051, S1000D, it becomes even more clear that you cannot only depend on validation errors. You will need to add more detailed checks because in this type of standards, data is being tagged according to information it covers and not necessarily according to the appearance. And I will show some examples later on. So similar to validation, you cannot only depend on rendering or publishing of the data. And you cannot really say if it looks good, therefore it's tagged correctly. Let's say you validate an XML file, a bunch of XML files, and you import them into a publishing tool and publish a PDF or an XHTML file to view the converted file. It's possible that things will display fine, but it will not guarantee that it was tagged properly. And a simple example can be if you have a two-column table and the first column is the step number and the second column is the step itself. For some people, it's fine to tag it as a regular table, but others may want you to tag it as a procedure and not as a count table, like basically a set of procedural steps. And the next item really surprised me when I first started to manage projects. Some people either don't want to or think it's not important for them to be involved in the process because they hired the so-called experts. And you should always be involved in the conversion process. You should also approve at a minimum the production sample or any kind of the major milestone, and it's especially important to be involved if you're planning to sustain the data. Understanding how the data migrated from legacy format to XML makes it a lot easier to transition to the new look and feel of the converted data. Last misconception is that people have the mindset of, just convert it to XML and we'll fix any small issues later on. In most cases, this is not the best approach, and you will see why in the next slide. So again, a common obstacle in conversion is that really people don't take into account something as simple as analysis in QA. There should always be an analysis phase to mitigate the risk of getting to the point of fixing the issues later on. Because fixing later is really not an easy task. So let's say you have a 5,000-page project, which is not a huge project, and it only takes 2 minutes to fix every page. The 2 minutes per page actually adds up a lot. And the fixing of the files can be something as simple as looking for references and fixing them. If let's say the conversion missed them, it can be fixing the hierarchy of sections, or fixing table structure, or fixing placement of alerts. And there's a lot of other scenarios I can think about that you may consider as a small fix, but it turns out to be a very time-consuming task. So the 2 minutes per page ends up being 24 days task of fixing items. And again, this could have been resolved by spending a bit more time analyzing the data properly. And really, those 24 days is a lot of wasted time and money that could have been salvaged by proper planning and having a proper QA plan. So the time and additional cost it takes to fix this issue is actually really the least of your problem. And fixing the items manually introduces inconsistencies. And if you have more than one person working on fixing the issues, I guarantee there will be even more inconsistencies added to the file. Also, if you make the changes and the files are not imported properly to your CMS or item or common source database, depending on what you do with the converted files, trying to fix and finding these issues will be a very expensive and time-consuming task. So in this example, you can ask two questions. First, can you automate the conversion? And the second question is, how do I QA an automated process? So for the first question, can you automate the conversion? The answer is a little tricky. It's very rare that you have a push of a button solution for legacy conversion, but you can actually automate most of the process. It may require you to prepare the data beforehand, and you will also need to develop and document the conversion rules, and also document how the QA process is going to work. But depending on what the source is, depending on what the source format is, the process may change a little bit, and also your QA process may change a little bit. If the source is paper, you'll need to scan OCR, proofread, style, and map the styles to an appropriate element, and you need to take that into account when developing a QA plan. If the source is already in Word or other ASCII format, you maybe save yourself the text extraction phase, but the process is still somewhat similar to other formats because you still have to prepare the data for automation. And if the source is HTML, XML, or any kind of other tagged data, you have a better starting point, but you still need to map the old structure to the new set of elements. And at the same time, also manipulating the data, in preparation for conversion, is actually a bit more difficult than the other source formats. So again, regardless to the source format, doing a manual QA is going to be a time-consuming task and not always efficient or accurate. In many cases, you can write a script that will do the job much faster and a lot more accurate than reviewing the data manually. But you obviously need to develop these rules and translate them into a script. And that will require additional analysis time. So again, there's really no escape from having a planning and analysis phase, but those are time that is well spent and will save you a lot of issues going forward. So some of the items that can be checked using a script, for example, you can have a para element that is starting with a number or something that could be a paragraph numbering, like the ones that are in blue, circle, and square. This could indicate that hierarchy tagging may be incorrect, or that a step or list should have been used instead of a paragraph. Another thing to check are keywords like paragraph, para, section, figure, fig, table, refer to, and a lot of other keywords that can be used, and see if they're followed by a number or character. And that could indicate a possible location where cross-reference should have been used, and maybe hasn't in this example. So if you, and again, if you know your source data structuring, such as the numbering schema that is used in the legacy data, it can make the search more efficient. It will also allow you to cover most of the variation up front, saving you the time and the effort that otherwise you will need to do to put into fixing the issue manually once they're already converted. And again, so I'm really a big believer in doing automation, but it's also important to know when automation stop being useful, or it's not worth the investment. Let's say you want to see if you use the step element or the list element properly. You can search for a verb inside an item, not inside the item element, and that could indicate that a step should have been used. You can also search for keywords such as steps or follow the steps and see if they're followed by the checklist element. And again, those element names can obviously change from standard to standard that you use, but that could indicate that maybe a step should have used instead of a list. So it's a good thing to know, but the problem here is that you could end up with so many cases to review that it might not be worth the time and effort to sift through all the warning messages in order just to find one or two, let's say, true cases. So tables. Tables for some reason can cause issues during conversion, but it really shouldn't be a challenge. And here are some examples of tables that look the same but appear in 3 different formats. And again, if the source is paper or PDF image, this is less of a problem because you have the opportunity to manipulate the data before the extraction phase. And again, during the extraction phase. And any zoning OCR tool will allow you to zone the table properly. And once the table is extracted to any kind of word processing, and again, we use Microsoft Word, but it's a lot easier to QA the table once it's already in ASCII format. So in the second example, if the source, if in the legacy data, the structure the table using a tab or spaces, you can convert it to a table where a tab indicates a new column and maybe a hard return returns a new represents a new row, and then you can visually inspect the table and see if the text went to the right location. And again, sometimes you may have 2 tabs, and sometimes you may have spaces instead of a tab. So you can actually create a script that will go and look if there are consistent uses of tabs and so on. If not, you'll have to do the work manually, but you always have to look for both options, manual and automation. So up to now, all the table checks we were doing were manual process, but you can use an automated tool to check the structure validity of a table. For example, you can check by automation that table headers done properly and marked as table headers. The automated tool can check if cells are missing or there are too many cells used in the table by the number of columns declared. And you can also check if cell merging and spanning were done properly. And again, we'll cover that more in detail later on. So, put aside tables, if you go to a more complex standard, where there's some tables that are actually tagged using content elements, things will be a bit different. So you have standards like 40051, S1000D, and so on, that some tables will display as table, but they actually, each row and cell of the table has actually a unique element associated with it. And there are a lot of examples of content tables, but this specific slide shows the PMCS table, which is the preventive maintenance checks and services table. And there are a lot of variation of the same table. And writing software to convert all the variation might not always be the best way to go. And in many cases, mapping this table to XML is not a very easy task because the table structure, table vary in structure almost all the time. And this is a great example where manual and automated process can actually go together. At some point you will need to map the source data to XML, and if you know you are going to have a complex standard or module standard, you need to know how to flag these items. So during the analysis phase, before conversion begins, you need to find these tables, and most, if not all, of the variation of the same table, and develop rules to handle them. This is why I always emphasize on the importance of proper analysis and documenting all the mapping and conversion rules. And again, in the past we had a webinar just about that subject, so I'm not going to spend too much time about the conversion rules and documenting the rules. Now, if this specific example becomes a cost table, you don't have as many issues to deal with, and you handle it as a regular cost table. And you can visually see if the text is transferred to the correct cell by viewing the XML, using, let's say, an off-the-shelf XML editor. And any one of them will display a cost table in a way that you can easily view it. And if, let's say, for some reason you don't have an XML editor, which is probably very few people that don't have it, you can actually create a simple style sheet that will display the data as a table, and you can view it with any kind of a browser. Okay, so if your data is already in a word processing format like Microsoft Word, it's fairly simple to build a Visual Basic script or any other kind of script that goes through each table and highlights the table header as long as they were marked as heading or repeat with Microsoft Word, and then you can see if anything was missed. You can have a counter that makes sure the number of columns do not change in the middle of the table, or that there are not like minor shifts in the column separator that during conversion can mess up the entire table. So you can do that, and I'll show you an example later on. And if the source is tagged data, it's easier to check the structure as the data is already tagged. So you can see if there are other inconsistencies with the element tagging if it's a tagged data. And again, there are other tests you can run to make sure the table structure is structured properly, but this becomes a bit more difficult when you deal with content table, because at the end of the day, it's not really a table. And and if you can see over here, and again, I put kind of the elements that belongs to every part of the table. You need to find these rules ahead of time and know how to map each and every one of them to the appropriate element. So, but at the same time, you can check that an interval, let's say, has the values of before, after, during, and so on, whatever is defined by the schema. And you can also check that the value of an item number is a number. And it gives you more opportunities to use automation to check the data. So if you do deal with complex standards, you will need, again, to take that into account during the conversion process. And if your source data is an ASCII format, Microsoft Word, or any other kind of ASCII format, it will be easier to manipulate the data to make the conversion more accurate. So for example, knowing in advance what specific content tables, a specific content table is supposed to look like, it will allow you to manually manipulate the data according to few predefined and developed templates. So you don't need to be a subject matter expert to prepare the data for conversion. You can also insert a bookmark in the legacy data to indicate to the software that this is actually a content table and not just a regular table. And because again, from the so many variations, you may not be able to use just keywords to flag these cases. And again, sorry, we keep going back to normalizing and standardizing your data. So for example, in the bottom table, the third column, all caps text, spanning over 3 columns, will indicate the title of, let's say, a PMCS proc. In a different location, it may appear in a different font or a different location, and by normalizing your data, you can use, again, a predefined template, and all the content table will follow the same consistency, and allowing the software to produce a very accurate tagging. And this consistency will allow you to check the validity of some of the cells. And again, like we talked about the interval and the item number, or PMCS versus PMCS paragraph, PMCS step versus PMCS paragraph. So when viewing the content table after it was converted to XML, you need to understand that it will not look exactly the same as the source data. And the reason is that the schema restricts the tagging to a specific structure. So for example, the equip not available column may now appear before, or may appear in a location where the schema forces it to be, and not where it used to appear in the source data. You may want to think about building a production style sheet that can be used to enhance the tagging. So here in this example, again, using a very simple style sheet, we display the data in a way that will make the manual review process a lot easier. And again, because most approved style sheet and FASI and XLTO that is useful for specific standard will display the table the way the standard intended them to be. And it may display properly, but you can't really tell if they were tagged properly. You know, you can tell the difference that something was tagged as a PMCS step versus a PMCS para, or if a query not available was tagged correctly. So for example, here the text whole exterior, and it was tagged as a PMCS proc, is displayed as bold text to let the viewer know it was a title, it was tagged as a title. If the text, let's say, appeared in a different column, you know it was obviously tagged improperly. And the other ways to make viewing a lot more easier, but this is, can be covered in a different webinar. So jumping around to another area where QA is crucial, and that's during text extraction. So here a combination of manual and automated QC is also recommended. And simply by improving the process, a manual QA can be very effective. And again, you can create new fonts. For example, 0 will now have a diagonal line to distinguish it between the letter, distinguish it from letters, from the letter O, or a line through the digit 1 to make it easier to distinguish it from lowercase l or the letter I. And doing this simple change in the font makes it a lot easier to tell the difference between problematic characters. Another simple change in the process that can make a huge difference in quality is that in most OCR tools, you can align the source image window next to the OCR data, like over here. And that way you can go character by character and see if it was OCR properly, and really do it in a very fast way that otherwise it would have been close to impossible to do when you have the whole window open. And again, and you obviously can, just one thing about the other slide is that you can obviously use the built-in tools that the OCR packages offer, like spell check and highlight the text that the engine was not sure about, but it will not cover everything. So again, once the data is extracted and is in ASCII format, you can easily write a script that will review the data. So for example, you can, and again, this is just an output of a simple script that was run on extracted data. and you can look for a suspicious combination of digits and letters, and as long as it's not a part number or password or something like that, it could indicate a typo. You can also look for extra and missing spaces before a period or before or after a dash, and that could indicate also an issue with the text. Or maybe look for a paragraph that begins with a lowercase letter, and that could indicate a broken paragraph. But again, on the other hand, you need to make sure that you're not overdoing it with automation checks. And you always get, you'll always get some false detection. So you don't want to sift through thousands of items just to find out one or two issues. So it's worth investing some time thinking about what you're going to flag and what kind of issues are going to be considered errors. And you may spend what you may think a lot of time analyzing, and which, let's say you spend only a day, it's worth it to spend another day analyzing, because it's going to save you a lot of time later on. Okay. Another way to review your data is by doing content analysis. And some of the major reasons for content reuse analysis are, first, you find duplicated data, and you can remove the duplicate data, saving you conversion costs and future sustainment efforts. You can find discrepancies. You can find the issues really before conversion begins, and eliminating these issues up front will only make your conversion more efficient and with less cleanup. And the third reason is that it allows you to normalize your data. And if your data doesn't match, it might be because of, let's say, writer creativity, or something as simple as using should instead of shall, or something, sometimes using abbreviation inconsistently. Regardless of what the mismatch is, it's an easy way to make your data more consistent. So in the first example, you can see that there's an exact match of a paragraph in 3 other manuals. And then you can go back and review it and see if you can create a section or even just a paragraph and reuse it 3 times. If you go to standards that really enforces reuse, like S1000D and so on, you can see if you can build a separate standalone data module and reuse it in numerous locations. And in the second example, you don't have an exact match, but it's close enough to indicate a possible reuse. So you can see that the first paragraph discusses model number FD5200, and the second paragraph is about FH5200. In this case, you still reuse the paragraph, but you can use applicability in standards like S1000D or effectivity in ATA to distinguish between 2 paragraphs, but still use only 1 paragraph in your data. And again, the other typo over here, not typo, the mismatch is that some use visually inspect, while the other paragraph use just inspect, visually inspected and just inspected. And again, you can go back and see it could be a typo, it could be a valid paragraph, but regardless, it gives you an indication of how consistent the data is. So a conversion specification is an effective QA document. It's created to manage and document the major rules of the conversion process. And again, you can look at it as a project-specific business rule, but besides being a great QA document conversion, again, besides being a great QA document, the conversion specification is a great method to have all the stakeholders on the same page. And again, we usually, this is just a simple example, but we usually document the elements that are found in the documents when during the analysis phase. Example of where the elements can be found within the documents, and a concrete rule is how these elements are identified, an example of how we plan to use them. And you can also include any kind of open items, any anomalies which are associated with a specific element, that you're not sure how to flag something. So all the issues are kind of documented in one location. And as you do the analysis and find more anomalies and structures that do not fit the schema, you'll need to go back and ask the right people for answers. And again, there'll be some discussion and several iteration before a final conversion is completed, but once all the open issues are resolved or agreed on, the final version of the specification is produced and approved by the client. And at some point, it's a good idea to everybody meet and walk through the conversion specification with all the players. And this, again, this step is critical to ensure that all the stakeholders understand and agree on all the tagging rules. And again, it's also one thing about this document. It's also used in developing the conversion software, because once you develop the rules, you translate that into a conversion software. And again, you'll be surprised how effective the conversion specification can be. And it's a very important part of your QA process, because you have one central document that all the stakeholders can use and agree on. And as I said before, it's a great way to have everybody on the same page. So again, the QA process depends a bit on what the source format is, but the benefit of having your legacy data already in some sort of a word processing format, or maybe even getting your legacy data into word processing format like Microsoft Word, obviously, it's that it's easier to normalize the data and prepare it for automated conversion. And having the data consistently styled and structured makes it a lot easier to QA using automation. So if you follow a simple styling guide, you can accomplish really few things. First, you make your data obviously more consistent by applying style, and the software can better translate the data to XML. You can also find discrepancies and structure that do not fit the predefined rules we set up front. You can easily build automated QA to first assist you with the styling, and also to check that the data is structured properly. And all of this can be done with a cheaper labor. You don't need even somebody that knows XML to style the data, because when you style, you do go by appearance. So, and again, and this is an example of a document that was styled, but because you're dealing with legacy data, things will appear in all forms and shapes. And sometimes, like, it's really like fitting a square peg into a round hole. And one thing you can check by automation once it's styled and normalized is consistency. And in this example, specifically in this example, you have step 2 jumps to step 4. You have number 1, number 2, number 4. And again, the reason could probably be from that maybe during text extraction, the step 3 was merged as part of step 2. And again, you can easily write a script that will find and detect these cases. But what may happen in this case, and that's where you have to, again, find the balance between automation and manual review, is in this case you may have graphic holdout that may be confused with step numbering. So if they start on a new line, it might cause you a problem. And again, here you really have to distinguish between the steps. But if you have automation that checks for it, it's a lot easier than somebody looking for the specific cases and going one by one and finding them. You also see that the page numbers are still maintained, even though that in most XML standards, the concept of pages goes away. And really the reason is for QA purposes, because by keeping the page numbers, you can track the text back to the legacy data. And this is especially critical when you restructure the data to the standard that you're going to, when it's a complex standard. You can see if pages were dropped. or if text flows properly. And again, this is easily done by software, simply by having a count and seeing if the page numbers are done properly. And the legacy numbers are also used as a bookmark to know when to reference to, when there's no clear rule. For example, if in the legacy data it says refer to repair procedures on page 2-124. So a script, a software can actually go to a page number, because it's done as a page number, and look for either keywords repair procedure or anything styled as a title. And if the software cannot find the location to a reference, it might indicate that a legacy data was wrong or text is missing. It could also indicate that maybe during one of the updates on the legacy data, the page number was never updated or the reference was not updated. But at least you get an indication that something is not correct, and you can add it to the anomaly report and decide later what to do with it. So again, a few slides ago, I spoke a little bit about cows table and content tables. We know that cows table, as simple as they may appear, may require a lot of manual work if you don't have a good QA plan. So if you have a table similar to the one here, you are dealing with a table that is spanning over many pages. You're also dealing with all the brackets. And again, these brackets are not so simple to represent in XML. And you can actually resolve this by merging the cells, just the ones that the brackets cover. So for example, in the first jumper, you can actually remove the brackets and merge the cell and have the jumper on the two rows over there. And if you merge the cells, you can ignore the brackets. Another issue that occurs because of the brackets is that you may end up with different number of columns on every page, and there needs to be a way to when you combine the table, to make sure that every table has the same amount of columns. And one way to mitigate the chance in having too many columns is to do two things. First, you can wrap the table with predefined pre-editing styles. The software actually knows that this is the beginning of the table and this is the end of the table. And the software can combine the many tables because they span over numerous pages and do a much better job than manually doing it later on. A way to make sure that when you have tables spanning over many, many pages, it's combined into a table with only, in this case, you have 10 or whatever, 13 rows. And you actually, we're talking about before, you can see that the table header is actually highlighted in yellow. And this is actually done part of the QA process, and the VPA tool, in this case is a Visual Basic, runs through the file, and if a row was actually marked as a row heading repeat, it will highlight it, indicating that this is going to become a table header. So again, if you see this yellow thing appearing somewhere else, you know that something was done improperly. So the final QA you'll need, that you will need is also to view the converted XML file. So once the data is converted, you need to find a way to view the XML files. And an easy way to view it is by creating a simple QA style sheet. Not using the final deliver FASI or item or style sheet. Have a style sheet that puts more emphasis on the tag and validity and less on making it pretty. So just as an example, and again, it can be anything. It's not necessarily, in this case, you may output the element, you may leave the original paragraph label, so you can always track back to the legacy data, even if it doesn't follow. You see how we jumped from 111 to 113. at least you have a way to track back to the legacy data. Later on, before final delivery, you can strip all those attributes or any kind of flag, the way it was flagged. You can always pull it out. Cross references, you can actually see. You can put a frame, but at the bottom it actually goes to the table instead of going back and forth, and actually have a QA that checks that you really go to a table. A lot of times we say refer to in a table, all these things as a specific element, each different column. The figure number over here is repeated twice, and you don't have a lot of time to spend and look at every page.
QA